Okay, in our lesson 4, we're going to be looking at what is called your distance formula. Hooray! See, you can play with everything, but one thing don't play with is your distance formula. You know, I've given you increment formula. Now we are advancing into your distance formula. Now, in distance formula, first, when is it used? When should I use it? Please follow me very fast. This is our lesson 4. And you must note that in your distance formula, first, it is used when the distance between the two coordinates are known. Only when you know the distance between the two coordinates, that's when distance formula come alive. And which one do we call your distance formula? Very fast, please. Your distance formula is given as this. Your distance P1, P2 is equals to the square root of x2 minus your x1 all square plus your y2 minus your what? Your y1 all square. Even if you are sleeping, you are jogging, you are stressed and tired, when they tap you, you must know distance formula. What's your distance formula? Your distance P1, P2 is equals to what? The square root of what? Your x2 minus your x1 all square plus your y2 minus your y1 all square. Distance formula is a must. You must know. So follow me very fast. More they utilize them. Where I want to go. Close your eye. Yarn me distance formula. I shock you, Abby. Distance formula, distance P1, P2 is equals to your what? The square root of, say that if I'm not do, you will leave that note, you will look me. Distance P1, P2 is equals to what? The square root of your what? Your x2 minus x1 all square plus your y2 minus y1 all with in square. Don't try me. Well, let's go. So if I have this as my coordinates plane, what should I know about distance formula? Let's prove it together so that we're going to see something lovely. In fact, there are 3 formulas. I'm going to show you some stuffs about under this very quickly. Now look up now. Let's say, for example, this is our point P1, and then we call it your x1, y1. And it's different from this second point, which is your P2. Just follow me, you x2, y2. Hold on. Why do we call this guy your P1, and then we decide to give it coordinates of your x1, y1? The reason is this is your x1, this is your y1. So x1, y1 belong to P1. This is your x2, this is your y2. So x2, y2, where will it belong to? It belongs to your what? Your P2, right? Okay, what if I call this guy here now P3? Say P3, you now rush and give it your x3, y3. No, now it's not like that. Your P3 there, the coordinate for it is going to be x2, y1. Sure, you see the reason why, right? So if I decide to say, okay, let's join my P3 and P2 together, we decide to join them together. And then let's join P1 and P3, and we decide to join them together. Now follow me squarely from here. We are going to prove distance formula. Know how it is proven, right? Now, if we join them like this, okay, makes sense. Let's take the distance from my P2 to P3. So P2 to P3, sure you are seeing the distance there, right? And if you trace this P2 like this, sure to come and land with your y2. If I trace P3, sure to come and land with my y1, right? It will correspond here very fast, right? That means, what is the distance between my y2, y1? Y2, y1 there is going to give me what? The absolute value of your y2 minus y1. That's how it is. Your y2, your y1, you trace it like this, right? What is it going to give you? Absolute value of your y2 minus y1. What about, okay. Can I trace my x1, x2, x1, you bring it down, x2, you bring it down. So if the two of them land like this, say you are seeing it now, what is the distance from x1 to x2? It's going to give what? Absolute value of x2 minus x1. And that is exactly what you're going to have there. Absolute value of x2 minus x1. So I know this distance here, right? And I know this other distance here very fast. What about, okay, if we now decide to trace and join our P1, P2? Yes. Picture it first in your head if I join it for you. Your P1, right? And then your P2. Can we join them together? If you join them together, you are going to have something of this nature, my brother. So you be my sister now. So if I'm joining my P1 and my P2 together, I'm going to have something of this. Now, follow me from here very, very fast. Same so we have here, but minimize now. Draws. I'll show you something more interesting. Now, there are 3 formulas I want you to hold tight. They're case 1. What happened in case 1? Case 1 is such that, okay, your x1 is not equal to x2. Pay attention. If my x1 is not equal to my x2, that means they are more like distance apart, and your y1 is not going to be equal to my y2. The two of them are distance apart. What happened there? Very fast. We can say, okay, from Pythagoras theorem, you know, this long side here that is P1, P2, that P1, P2 side like this that we have, it's more like the hypotenuse, right? Oh yes, from Pythagoras theorem, is it okay for us to say that your distance P1, P2, distance P1, P2, this long side here is equal to distance P1, P3, distance P1, be tracing them, distance P1, then P3, right? Oh yes, plus distance, your what? Your P2, P3. Very simple. Pythagoras theorem, so we have applied there. Where the square of the hypotenuse is equal to the sum of the square of the other 2 sides. That's what we have done there. That means, can I prove something more interesting for you very fast here? What's my distance P1, P2? What is it going to give me? Distance P1, P2 square from this formula is equal to, what's your distance P1, P3? Distance P1, P3. Of course, what is the value there? Absolute value of my x2 minus your x1, absolute value, then I'll square it, right? Plus, I'm applying this formula now. I've applied this, I've squared it. Plus, what is P2, P3? Your P2, P3 is absolute value of your, of what? Y2 minus Y1. That's absolute value of your Y2 minus your what? Your Y1. Then like this, then I can square it, right? Square it as well. If I have done that, that means, what is my distance? What is my distance? Distance P1, P2 square. What is it going to give me? Is it okay for me to write it like this as x2 minus my x1 square plus my y2 minus y1 square? Yes, it's very okay. So if we agree that, okay, based on 1 or 2s, it's okay, we can write it like that. Now follow me. We are looking for distance P1, P2, not distance P1, P2 square. So if I take the square of both sides, the square root of both sides, now for example, now I take square root here, and I decide to come and take square root here, what will happen? Can square come and cancel square roots? Yes. So what is my distance P1, P2? Distance P1, P2 is going to give me the square root of what? There, very fast. X2 minus X1 all square plus your what? Your Y2 minus your Y1 all square. This is called your distance formula. What is it called? Distance formula. What's your distance formula? Distance P1, P2 is equals to the square root of your what? Very fast. X2 minus X1 all square plus your what? Your Y2 minus Y1 all what? Square. That is your distance formula. If you are sure you understand and you know your distance formula, this is your case 1. When I just say case 1, I just understand that the real distance formula with that. Look at case 2. Hold on a bit. As far as 100 level is concerned, right, for both first and second semester, your complete series of classes, including your practicals, everything from beginning to the end is in the LearnLift app. All you have to do is just march down to your Play Store or App Store and download the LearnLift app, and then you're going to have access to every singular class. So just move down to tertiary, click on tertiary plan, where you're going to see all your classes as far as your 100 level is concerned. And guess what? Your video lessons are there, your CBT is there, you have access to your past questions, you have access to your notes. Very, very important. Man, this semester, you must do well. Anyway, let's proceed quickly as we march down to our class and continue our class. Enjoy. In case 2, what is it that can possibly happen in case 2? Very fast. Now follow me very quickly. In case 2, it's possible that my x1 is equal to x2. You know that we said in case 1, x1 is not equal to x2, and then y1 is not equal to your what? Your y2. But it's possible that in case 2, x1 is equal to x2. What happens when x1 and x2, they are the same? It means they're not going to have this kind of distance that we have here. If they are the same, that means that point that we are locating or pointing out as s1, that same point is x2. And when that happens, see here, follow me first. So you know your distance formula, right? Your distance formula is what? Square root of your what? Your x2 minus your x1 all square, right? Plus my y2 minus your what? Your y1 all square. Now follow me very fast. If x1 and x2, they are the same and they are equal, that means what is x2 minus x1? That will be 0. If it is 0, listen, when x1, x2 and x1, when the value of x, they are the same, that means they lie on the same vertical line. But sir, I thought x is on the horizontal axis. Yes, x is the horizontal axis, but when x1 and x2, they are the same, where are they lying on? They lie on the same vertical line. On the same vertical line is where they are lying. And what formula will I use when x1 is equals to x2? The formula is simple. The formula is your distance. P1, P2 will give you what? Square root of x2 of your y2 minus your what? Your y1 all square. So because your x2 minus your x1 is what? 0. Try me, may you see. I will show you shaggy. Try me. I will scratch your eyes. Try me. What I'm saying is you must know this very quickly. I've given you case 1. Case 1 is when x1 is not equal to x2, y1 is not equal to y2. What is your distance formula there? Distance. P1, P2 is equal to the square root of x2 minus x1 all square plus y2 minus y1 all square. That is what you are going to have there. But when x1 is equal to x2, what happened? They will both lie. P1 and P2 will lie on the same vertical line. And when P1 and P2 lie on the same vertical line, what happened there? Your distance P1, P2 is going to give you square root of your what? Your y2 minus what? Y1. So you will forget everything about x or what square. That's what you're going to have there. In case 3, what happened in case 3? By now, you should already be realizing what should happen in case 3 when y1 is equals to y2. Abi? Now listen, when y1 is equals to y2, what happened? Then P1 and P2, will they lie on the same vertical line or on the same horizontal line? On the same horizontal line, so they will lie. And since they will lie on the same horizontal line, please, no stress. That means your y1 minus y2, your y2 minus y1 all square will give 0. What do you just use there? You're just going to use your distance. P1, P2 is equals to what? Square root of your what? Your x2 minus x1 square or square. That's what I'm going to have there. Shey is very simple. When y1 is equal to y2, nothing concerns us and y anymore. We're just going to use x. When x1 is equal to x2, nothing concerns us and x anymore. We're going to use what? Y. And don't forget that when y1 is equal to y2, they will lie on the same what? Horizontal line. But when x1 is equal to x2, they will lie on the same what? Vertical line. Now, please, a quick reminder, just know that case 2 and case 3, they are special cases. Special. So it's not every time they come up. But the one that you always see every day that we call distance formula, now this guy. Distance formula, which is case 1, distance. X and P1, P2 is what? Square root of what? X2 minus x1 all square plus your y2 minus y1 all square. This is called distance formula. Try me. If you understand this very quickly, that means we can take some solving, right? Yeah, let's go. Let me show you something here. Look at question 1. If we are given a question like this, find the distance P1, P2 between the points P1 and they gave the value and the points P2 and they gave the value. Now follow me very fast. What's your distance formula? Your distance P1, P2, right? What is it going to give you? It's going to give you the square root of what? Your x2 minus your x1 all square plus your y2 minus your y1 all what square. That's what we're going to have. But now, sir, what is your x1? What is your y1? This guy is my x1. Here is my y1. Here is my x2. Here is my y2. Follow me, yo. So that means, therefore, that our x1 is equal to what? Minus 1. Yes. Your x2 is equal to what? 2. Yes. Your y1 is equal to 2. Yes. Your y2 is equal to what? Minus 2. Trace all of them and see. Now say that will give you what is the square root of x2 minus x1. x2, that's 2, minus x1. What is x1? Minus 1. That means 2 minus minus 1. Then you close the bracket like this, all square, plus y2 minus y1. What is your y2? Minus 2 minus y1. What is your y1? 2. All square like this. This is how I'm going to have. Oh, yes. That will give you the square root of what? 2 minus minus 2. What is 2 minus minus is plus. That's 2 plus 1. That's how many? 3. 3 square plus minus 2 minus 2 is minus 4. And what do we have it to be? That will be minus 4 square. And that will give you the square root of what is your 3 square? 9 plus minus 4 square. What's minus 4 square? That's 16. Because 4 times minus 4 times minus 4 is plus 16. Of course, now show 16. That will give you square root of 16 plus 9 is 25. And what is the final answer there? 5 becomes the correct answer. So what is the distance between P1, P2 and then distance P1, P2? What is the answer there? 5 is the correct answer. We have solved it and then you are out of there. Simple. So you see now. Look at the second question, question 2. Question 2 says find the distance between the following pairs. And then they gave A and B. Now follow me, shop me. What is distance AB? You know, if they give A and B, of course, and you use this as AB, what is it going to give you? The same formula. Square root of your what? X2 minus X1 all square plus your Y2 minus your Y1 all square. This is what we're going to have there, right? So if I have that, don't forget that this is your X1, Y1. This is your what? X2, Y2. So what is our X1? X1 is what? 2. And what is our X2? X2 is how many? 5. What is your Y1? Y1 is how many? 3. And then what is your Y2? Y2 is how many? 7. And then you can solve. So this is going to give me nothing but the square root of X2 minus X1. What is X2 minus X1? That will be 5 minus 2 all square plus your Y2 minus Y1, 7 minus 3 all square. And that's going to give you square root of 5 minus 2. What is 5 minus 2? That's 3 square plus Y2 minus Y1, 7 minus 3. What's 7 minus 3? 4 square. And that will give you the square root of what's there? 3 square is 9 plus 4 square is how many? 16. That's the square root of how many? 25. And what's square root of 25? She's saying 5 again. So this is the answer. Very simple, easy, and direct. You just apply the formula and then you do your normal solving and then you get out of there. That's all. She said that is very simple, easy, and direct, right? Oh yes. Now that you understand this and you are sure that you get it very, very well, there are still more questions on that distance formula. In the next lesson, I'll solve it for you very, very fast. Okay? See you there. Enjoy. Catch, shower, and love. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.